Welcome back to AutoTechNick, and in today's video we're going to be kicking off the timing belt service on this 1997 Ferrari 456 GTA. So for the subject for today's video is this 1997 456 GTA. Now this is a very clean car, quite low mileage, about 15,000 miles. And on our last video you guys saw me work through the pre-service inspection where I went over this car from tip to toe. That's a complete mechanical, cosmetic, functional inspection of the car. We also do some specific things up here in the engine. I smoke test all of the exhaust manifolds, do our compression tests on the engine, also run through, get our emissions gases from the engine, hooked up our SD1, read all the faults. So doing all that gives me a really good understanding of the condition of the car and its needs. So you can see that I put a plastic cover over the car, and that's just to help keep it clean while it's in the shop, because really I'm not going to be doing much work at all to the back of the car. All of my effort and work and attention is going to be focused up here in the engine bay. So just like the series of videos I made on the F355 where we did the engine out service, my goal is going to be showing you guys step by step how I work through the timing belt services, except this time on the 456. Now I will start with a bit of a disclaimer where I make a lot of references to other cars throughout the series of videos. And specifically on this car, I'm going to probably end up making a lot of references to 456, 550, 575, and 612. And that is because they all use essentially the same engine. The engine is different in between each car, but it's the same philosophy, it's the same platform, and they share a lot of similarities, and there's also little things that make them different from one another. So in some ways, I group them all together in one, as they're all 65-degree belt-driven V12s. That's the only cars with this engine. But there's a lot of things that make each one different, so I'll kind of talk about those along the way, things that you need to keep an eye on, look out for. And I'll also probably end up making some references of how this engine is similar to the engine that we had in the 355, because these 456s are made in the same era, and typically Ferrari does things the same depending on the era that they made the car. So although this is a front-engine GT car, a 355 is a mid-engine sports car, you're actually going to see a lot of things that are very similar and very familiar. So that's really my objective with this series of videos, is walking you through the process. Do you get the belts on? We're going to talk about degreeing in the camshafts. We're going to go through the valve adjustment and really all the things that are different from this service to the last one we did, and also probably touch on the things that are similar. Now the start, one of the biggest and most obvious things is being a front engine V12. We actually have the space that we need up here at the front of the engine to get into our timing belts and to degree them. Therefore, we don't need to take the engine out of the car. Now, some people instantly think that just because we don't have to remove the engine from this car, this belt service is a lot quicker than a 355. And I'll tell you that's really not the case. The scope of work that we're doing is very different than a 355, but the overall amount of time that it takes to get this job done compared to a 355 is pretty much the exact same. I actually charge the exact same amount of hours to do an engine out on a 355 as I do a 456. So we won't have the time invested on this 456 to get the engine out, but it does slow us down getting the timing belts on, tension, and degreed with the engine in the car. Also, we have time that we need to account for on doing the valve adjustment. So really, when you add up all the overall scope of work for each job, they really end up taking the same amount of time. Although I don't have to take the engine out, it's not as spacious, or I don't have as good accessibility and, such a good view on everything like you do the 355, where a 355, it's a little bit of work to get the drivetrain out of the car, but once it's out, you have days of space. And here, we're going to be working around a few things. All right, so let's just dive right into it, and let's start by getting our airboxes off. Now, I will say that when I take these off, you can see that I already have it unbolted from the airbox bottom. I usually disconnect my harnesses here, so my intake air temp, my airflow meter. Down underneath, you're going to have to disconnect your idle valve and our TPS sensor. I'll take this harness, route it, and move it out of the back of the way. Then I loosen up all my hose clamps. I try to leave this all as one, so I'll loosen it up off the throttle body, take my idle air hose clamp right here off, and you're going to have to pay attention to this hard vent line right here that's coming in right there. Take that off, and I should be able to pop this whole air boot, elbow, airflow meter, air cleaner lid off as one assembly. And really, once we get those off on either side, it's really going to start opening up the engine bay and giving us a lot more space. All right, that wasn't too bad, pretty quick and easy, and it gives us quite a bit more space and access. Now, the next thing I'm going to tackle is our lower air boxes here. And, well, you know, you probably could work around these by leaving them in the car, but they're pretty easy to get out, so I prefer to pull them. They give me much more space while I'm working up here on the front of the engine. Now, to get these out, you can see right here I have one small 10mm nut on each side, but the rest of the hardware is actually accessed from the bottom side. So let me get the car raised up, and I'll show you how to get these air boxes removed. All right, so we're underneath the right front airbox here at the front of the car, and get up in there and show you. You can see right there. Let me see if I can successfully zoom in. Right there, you can see the lower mount. So that's a 10mm nut, and usually, or there should be, two washers. There's a larger washer on it and a smaller lock washer or wave washer. So once you remove that nut, expect to have those washers coming down. So we need to get that one out, and we'll spin around over here, and kind of right there you can see it. We're kind of right up in the inner fender area here, right kind of by the brake cooling duct, and you can see that other mount right there as well. So we got to pop those out. I will say, we come over here to the driver's side, it's a little bit tighter because we got power steering hoses and ABS hoses, oil cooler lines, but you can see that bolt right there. And this side gonna be a fair bit tighter. Yeah, see, this side we have chassis mount blocking the way, so we're gonna have to work a little bit more to get that last one out. My go-to, just a really long extension or the 10 swivel. You can get those out, and honestly the worst part about getting those, really that's not too bad getting them out. It's the hard part is getting them back on, because obviously you're fighting gravity with those washers, but that is not a problem for today. That's a problem for later down the road. So I'm going to pop this hardware off, and then we'll get to the top, pop it out. We should be able to have the airboxes out, and then we'll move on to our next step. All right, so I figured I'd show you how I'm getting to the rear mount over here on the left side, which is the one I couldn't show you. You can see I'm on the front side of the front section of my inner fender, in between the frame rail and the brake duct, and I have access to get up on there. On the other side, on the right-hand side, we got it from this side, basically on the other side of this duct. So from here, you get right up there and do it. And I will say that when you're putting this back on, you actually can get your hand up in there and usually get your hand to get the hardware started, or at least get the washers and nuts on, so it's not as bad as it seems. I just wanted to drop in here and show you guys how I get to this real quick. So with our hardware on the bottom off, just one more nut up here on the top side, and should be able to just pop this guy right on out. Got the nut off. Here's our magnet for the two washers. There we go. And we kind of have to be careful of our vent hoses here on the side. Put it up and off, and we have it. On to the other side. Now look at all that space we have up here. So you can see that we have ample room in between the radiator and the front of the belts, so that way we can do all of our work to degree the camshafts in, set our belt tension, all of our tooling. And you actually notice this radiator sits at a pretty steep angle, meaning down here by the crank we actually have a lot more space than we do up here at the top. And you can see here's our mounting points of the airbox. You can get a good view from the top side, so you can see everything underneath that we're fighting with to get there to them. And our forward mount up there. We got that stuff, we got plenty of access now, and I've mentioned this, we're going to be degreeing the camshafts in, which in order to degree them, you have to pull the valve covers. Also, during the service, we're going to be doing a valve adjustment, so we need the valve covers off the engine. Now, I've seen some people that prefer to leave the entire intake manifold on the engine and only pull these plenum halves here off to get the valve cover off. That's not the way I go. I prefer not to do that, and really, the main reason for why I don't do that is our intake manifold gaskets. They commonly go out on these cars, and really if you pull the intake manifold and replace the gaskets during your belt service, that lets you get access to degree your camshafts in, but that periodic replacement of the intake manifold gaskets prevents them ever from having a failure while the client is driving and using the car. So basically we're proactively replacing the gaskets so there's no problems down the road, and I've had good success doing that way. Plus it's like 2 1/2 dozen to the other. versus taking these plenums off versus getting the entire intake plenum off of the engine. You have more working room with the entire intake manifold off versus just the plenums. I really think it takes maybe just a little bit more work, but in the end it pays off with more space and you have the fresh gaskets. So I'm going to start by getting the fuel rails out. So you can see we have easy access to our wire harness for our fuel injectors. You don't really need to worry about where these go. The way the wire harness is installed and bolted to the intake manifold, you're not really going to get those confused. So we're going to pop off all of our connectors, our vacuum lines here to our fuel pressure regulator, our supply and return lines here to the fuel rail, and then we can just take off these small Allens, take out our fuel rail with the injectors off of the intake manifold, and that's going to give us access to our intake manifold bolts. Also, we're going to have to deal with the wire harness over here. It's kind of dim, but there's a plastic connector that you can either open that up with a pocket screwdriver, or you can rotate this 90 degrees and slide that out of the bracket. We have that to deal with. We're going to have these vacuum hoses here that run up and bolt on underneath the plenum. So once we get it lifted, we're going to have to take those and loosen those up and get them removed from the plenum. We're going to have another vacuum hose over here. You can see that this is the other one for the other side right here. So we're going to have to deal with that where it runs. Let's see if I can get you guys in there. You can see that screw right under there, right underneath the throttle body or behind it. We need to get those taken off so we can get this plenum off. And lastly, all the way back here, I can't get my hand back here right now because these lines are the fuel rails. There's two round barrel plugs or cannon plugs for the fuel injector wire harness for the left and right side. We'll need to disconnect those. And I think that's really all the things we need to disconnect, with the exception to the intake manifold bolts that we're going to access through here, but I can't really show that to you now because I have the injectors and fuel rail still in. I'm going to work to get all that stuff disconnected and off, and I'll bring you back and show you those bolts to get the intake manifold itself removed from the engine. Well, I got a little ahead of myself and I overlooked three things that are definitely worth mentioning. Now, the first one is this vacuum line that I showed you on the other side that runs in and ties into this nipple right here, back behind the throttle body. There's a bracket right here that is bolted on with one of the plenum bolts. Let's see if I can get a shot in there and show you guys that. Drop you in maybe right here. You can see right there. So we have to pull that plenum bolt out to pull that bracket off because this hose does not come off with the intake manifold. Neglected to mention that. Also, our throttle cable here. So there is an 8mm nut right at the bottom of this. Let's see if I can get a view that's worth seeing right there. So we need to take this 8mm nut off, which is going to let me take this lower heim joint off of the throttle bracket here, or off of the linkage. We leave this upper one on, and that lower joint is our actual throttle cable that runs back and into the car. So we will eventually take this stand off of the cylinder head right here for that throttle cable, but we need to pop this off because this rear throttle cable stays with the car. This forward throttle cable stays with the intake manifold throttle bodies, so we can leave that on. We will need to loosen this bracket right here, and there's those Allens, and I actually use a long ball Allen to get in there to where I don't need to take this cable out of this aluminum bracket because that will affect our adjustment. So you can get in there at a little bit of an angle, get those popped off. And it has these plastic clips here on the cam covers. You can snap that out. These frequently do break. They get brittle with time. It's a pretty tight fit. Not a big deal. They are replaceable separately. So if you just have one that's broken, just order the part and get that replaced. And do also keep an eye on your cable itself because they do tend to crack. The sheathing cracks over time. So that's one thing to keep an eye on. But we'll need to get that done. There's another clip here, another clip here. And then that's going to allow us to take this cable off with our entire intake manifold. Now you'll note our cable right here is running underneath our coolant pipes, and that's another thing I neglected. Honestly, I was trying to wait till the end of the day to drain the coolant out of the car so that way I didn't have to deal with the mess and I could let everything dry overnight. But that kind of bit me. Honestly, normally the first thing I would typically do is drain all the fluids out of the car. So I deviate from a normal procedure, and it got me here because I'm going to need those coolant pipes off in order to get this throttle cable off. And also we're going to need to get all these vent lines off right here for a crankcase breather box right here, which I was dragging my feet on those lines because I didn't have the coolant hoses off. So really I kind of bit myself by deviating, but not a big deal. I stopped. I've already got the coolant drained. You can see that I have all the hose clamps loose. I have loosened this lower hose clamp with this hard pipe on the radiator. So just a little bit of wiggling, I'll be able to get all my coolant pipes off. Then I'm going to continue getting everything disconnected on the intake manifold like we initially planned. And we'll proceed to get this intake off of the engine. Okay, so we have everything that we just spoke about disconnected from the intake manifold. Got all of our coolant pipes off. I also loosened up these breather pipes so I could get the throttle cable up on the top side. And I'll show you, I just took my lines off, those vacuum lines over there, and I actually just kind of route them back in this area, kind of like the fuel lines running forward. Everything just kind of wants to lay in this area and it's out of our way while we're doing the service. So that's kind of where I just tuck everything up in there. On the top side of the intake manifold, I've already gone through and removed all the intake manifold bolts over here on what would be bank 1. I haven't done bank 2 because I was going to show you guys how I do that. And if you look right down there, there's a small little 10mm nut right there. And they're not super tight, but I'll just spin them off. Now the thing is obviously this one we have a lot of access, it's easy. I spin them off and try to leave them on top of the stud. Again, this matters more so for these back ones. If it doesn't want to stay in the stud, I try to get it to fall right in that little cavity. You can probably see up there, there's that cavity up there. So that way I can keep track of the bolt and I don't lose it. I've seen some people try to use like magnetic sockets. I haven't had that great of luck with them because you can't get them that deep on the head of the bolt. And universals and stuff, so this is just a maybe 10-inch long wobble extension with just a 10mm on my 1/4-inch ratchet. It's nothing fancy, but you can see right here that it lets me get in. That's the second bolt, and you kind of have to zigzag where I come in on this other side of the runner. And if we get down there, give me a second. Yeah, we need a light. There we go. So got a light, and you can see how I have it on the other side of that runner bolt. And then if I'm to get the other bolt right here, so you can see that little pocket right there, pop it off and run right there. So I just work my way getting all of them done. I do it by hand. I don't use a power tool because a power tool I found will spin that bolt off quicker than I want and have a tendency to fling it where it will fall down into the valley. If it does fall in the valley, we're going to have access to get that bolt back out when the intake manifold is off the engine. But really, I try to have all the bolts accounted for and off before I lift the manifold because that eliminates the possibility of anything getting into an intake runner. Now, these nuts that we have on here, they're flanged, see right there, and there is no washers on them, so we don't have to worry about washers. We just have to be sure that we get all of the nuts off. There's 6 runners on each side, 2 nuts per runner, so 24 per side. Just go through, count, make sure you get them all. I think once I get these last row of nuts out, I'll be able to lift this intake off. I've already came back with the fuel lines out of the way, and I have removed the plugs I was talking about for the fuel injectors. So the last person that worked on this, they put some tape on it and labeled them. I can tell you that you can plug them in incorrectly. There's the second one right there, so you can cross these and plug them into the opposite side of the engine, which I have actually seen before on a car. It came from another shop after having a time belt service. Since that time belt service had a long history of check engine lights and really no one could get it sorted and get it figured out. Long story short, I got the car, I was looking at it, and they had the O2 sensor, or not the O2, they had the fuel injector plugs swapped bank to bank, but they also did have the O2 sensors swapped on the primary O2 sensors because the ECUs were not seeing the fuel trim adjustments they wanted to. So at some point they swapped the O2 sensor wires as well, and everything was still running backwards and out of whack because it was basically the front O2 sensor wasn't corresponding with the rear O2 sensor, which on these cars they still do monitor the rear O2 sensor slightly for fuel trim. So that was what was setting the faults. It was ironically enough O2 sensor aging faults, which this car has as well. So naturally, when I was looking into that on this car, I double checked all my wiring and connections to be sure that they're correct. Just be aware of that. Once we have the intake off, I'll be able to show you how they're routed. So it's pretty simple to make sure they're on the right side. All right, so I got all the intake manifolds out and accounted for. And what I didn't mention is when I loosen them with my 1/4-inch ratchet, I actually come back with a retractable magnet, and that's what I use to get each nut out of there. And I'll actually use the same method when I'm putting them back together. I can use this magnet and get them just started on the studs, and then I finish everything off with my ratchet. It's not really that hard. A little bit of dexterity, I guess, and a little bit of practice. It's not too bad. I've seen, like I said, I've seen everybody do all kinds of different methods to get those nuts on there, and this is just my preferred method. I find that it's actually quite quick. We mentioned everything's disconnected. We're ready to remove the intake manifold. I wanted to just kind of make a reference or a mention that these intake manifolds, well, this particular one isn't too bad, but the later ones are quite a bit heavier, especially where they have the third plenum on them on the 550, 575. Also, those later model cars, you can't reach back here and disconnect the wire harness for the fuel injectors. There's just not enough space. It's far too tight to where you actually have to take the intake manifold, lift it up, move it forward, then disconnect everything, and then take the intake manifold off of the engine. I'm saying all this because on those later cars, it's just wildly easier to grab an extra set of hands, have one person on either side of the intake manifold to help get it lifted up and off the engine. It may have a few vacuum lines that you need to get disconnected while you're there as well, so it just really makes it a lot easier. This intake manifold, it's not too bad, and it's pretty manageable with one person, but depending on what car you're working on, you might want to do two people. Honestly, if I had another person here to help me with this, I would definitely grab them because it just makes it easier and ensures that there's going to be no problems getting it off. However, I don't have that option right now, so I'm going to need to set you guys down so we can get this intake manifold off. All right, hoping I don't have any forgotten about vacuum lines on this. And making sure we're free. All right, I can already tell this is going to be a bit more awkward than I want. Get that lifted up and out. What am I caught on? Already can't see and caught on something. There we go. We got vacuum connection. Everything looks good. There's something over here. There we go. Got it. Lost the fender cover. Now that we have the intake manifold off, I have a couple things that I wanted to talk about and show you. And to start with, we'll come right over here to our intake gaskets. And you can already see, if you look at that red silicone ring around it where it's deformed, but you can actually see right here, that's split completely, and it's just completely coming apart right in the center. Actually, I can probably tear it all the way. You can see that. So this is what I was talking about, these intake manifold gaskets. They tend to go out and fail, and this set was well on its way, and it's a good thing that we are here doing it now, getting them replaced. Now, I will say that on this particular car, Ferrari calls out timing belts to be replaced every 3 years. Don't want to get in the subject of what is the proper interval on timing belts right now. I think that's a subject worthy for its own dedicated video. But I will say that this car is pushing, I think, 12 years since it's had timing belts. So those intake manifold gaskets have been on there for an incredibly long period of time. So I'm just saying this as in, if you're even doing every 5 years on your timing belts and replacing those gaskets, you're going to be fine. This is a bit more of an extreme or extended case. But now that we have a better view, you can see right here is the connector for the left-hand fuel injectors, which are going to be firing into this bank. However, that's the airflow meter, TPS sensor, and idle valve that's all controlled over here via this connector. And now you have a good view where you can see that wire harness comes and where everything goes and comes back and crosses, and that's where it makes that change. So when you're diagnosing the car on the top end, when everything's running, you just have to keep in mind that although we're over here on the right-hand side of the engine, this all feeds into the left-hand Motronic, and you just kind of have to get your brain memorized or keep that fresh in your memory so you know, because it can kind of get you a little confused, send you down the wrong road. So these are those connectors I was talking about, where they should be following this side that the wiring comes from for that particular Motronic. So on that car that I was referencing, they had these connectors crossed like so. And this is something on like this particular car, I could look back when the car was assembled and I could get my hand in there and see and feel that these were connected properly. So we got that. Up here on our valve cover gaskets, you can see it's starting to slide out right there in the corners. Again, up here, this one is actually pretty bad, where it's starting to come out and slide out. Pretty normal and pretty typical. So once we have the valve covers off, we're going to go and do our modifications to the head and the valve cover to peen it. Kind of creates like a raised area, kind of like a knurl, and that's going to help give that some bite so that doesn't slide out, and that will help prevent that from happening in the future. While we're here, take a peek at our head studs there. They are external, just like that 355 that we did valve guides on. Same tool you use to get the heads on and off, and it's pretty much the same setup. And I'm looking here on these ones and I'm seeing a lot of fresh moly grease on it. So I think at some point, semi-recently, this car probably had some valve guides put into it. I was looking on the inside and it looks like a bronze type valve guide, not a sintered. And it looks like this car had a fresh valve job or a top end rebuild not too long ago. I'll have to talk to the client and see what he has in his records, if he has any indication of that. That's good. I mean, our compression test came out really strong, so don't suspect any issues there, and it would make sense if that had recently gotten guides done. One thing I do that you don't have to do for part of your service, I will disconnect this connector right here. I'm also going to take these two hose clamps, loosen them, and rotate them 90 degrees. And that is because I have this little board that I made. I also have these that I'll put on the cylinder head ports to keep anything from getting into the ports while we're working on the car to help seal it off. But I have this board here where I'll slide up into here. You can see it doesn't fit. That's why I move these, disconnect this. I'll also unbolt this bracket right here for this wire harness, and I lay the harnesses in the valley. That's after I plug the intake ports with our little covers there. And once I do so, this sits right in the valley in the center and allows me to set all my tools and cam caps and everything on the center of the engine while I'm working on it. One thing that I try my best effort not to do, and that is to not set tools on the car. So it's a hard habit to break. It was definitely a hard habit to get new technicians to break when they came into the dealership. This car is not a workbench, it's not a tool cart. If the customer comes in while I'm doing the repairs, even if, say it's not his car and he sees that I have all my tools just strung about the car, that doesn't give him a lot of confidence on how I'm caring for the car and how I'm, how diligent I am and careful I'm being with it. It just really sends a bad message. So it's one thing that I try to make the highest effort to do, to not set my tools on the car. I mean, the only exception is always my light. I need to set my light down to do things. But if you guys keep an eye on all my videos, go back to that 355 series I worked on, very rarely will you see me setting the tool on the car, even if it's on a fender cover, even if it's on the engine or subframe. It's just something that I try to avoid at all costs. So this little board here, that is my little gray area, because once I get into the camshaft timing, the valve adjustment, this comes in very handy and really makes it a lot easier, and I'm okay with doing that there. I'm going to take a couple minutes to get that all set up and configured, and then we're going to temporarily steer away from our valve covers and engine and start working on the front of the engine, getting down to our timing belts. So everything's doctored up in the valley, and you can see that I got the wire harnesses all unbolted, laid down in there. My coolant temp sensor is disconnected. I moved my clamps, and I'll show you, although this doesn't fit all the way because we have our valve covers on still, but then that lets that sit right up there and gives me a nice little tray of the set tools while we're working on the cylinder heads and the camshafts over here. So we got that out of the way, and it's ready for the later steps. And where I'm going to focus my attention to now is getting this breather box off with our breather lines. So this side's super straightforward, nothing to worry about. Grab that light. We'll have to come over on this side and disconnect the two breather lines here from the oil tank. These two are already disconnected. See right up there. And then we have that other small hose right there running down from the bottom of the box right here. So we'll have to disconnect this rubber hose right there. And then it's just two 10mm bolts, one on either side of this box. And we can unbolt the box. And then we're going to have to work this hose right here with this junction out underneath this oil cooler hose. So a little bit of finagling and wrestling to get that out. And once I have that out, I'm just going to shift my attention here to our plastic belt covers. So start with the power steering cover right here. It's pretty basic, just pull all these Allens out. Power steering, and then drop down to the bottom to do the alternator and AC compressor belt cover down here. And then we'll be able to get each camshaft belt cover off right. These ones have these small 8mm on the back side all the way down. They kind of follow down on the back side of the engine if I get a view there. So you'll want to loosen all those, and this back cover plate that's here will kind of be free and loose. Then you'll know you have all that hardware off. And then I work to take the front of the cover off. So let's get after it. So now with the front covers off, we have good access to our AC and alternator belt back there in the rear, and this one is our water pump and our power steering belt up here in the front. I also did go through and removed all the hardware for our back dust shields on our timing covers, but you can see that the timing covers are still left on. Now, the bank one timing cover here can just be pulled off if I loosen all the mounting hardware, no problem whatsoever. However, the bank 2 cover will not come off until we have the belt off. Now, rather than just jumping straight to getting the belts off the car, I stopped for a second and grabbed my belt tension meter. So this is my frequency meter. It's a Continental tension rate. This one happens to be an optical meter, which is a pretty high-end unit. And I used that to record my belt tension on both belts before I made any adjustments to them or loosen up the tensioners. Now I'll bring you over here and show you that you can see I have a reading of 134 hertz on my power steering, and my spec is 120. So my power steering belt was too tight. My AC belt was 224 hertz and the spec is 160 hertz. So again, AC belt was also too tight. Now I was not the last person that did the timing belt service on this car, but let's say if I happened to have been the last person that did the timing belt service, with this information that I took here, I would have been able to go back and look at my records from when I put the belts on initially and see what they were tensioned at then, and then I can see how much that tension changed over time to where they are now. So it's really just more information that just really helps educate you over the years. Checking the tension before the service is just so quick and easy, there's really no reason not to. Now that we have that information, it's time to get the car in the air so we can get the belts off. All right, now we're underneath the car. We're looking here at the power steering belt. And right there, we're gonna have to loosen that 19mm nut that holds the idler pulley in place. And then we'll drop over here, and this screw right here will run that pulley up and down. It's a 19 as well, so I use a long extension with just a little hand ratchet. And we're gonna take this pulley and run it up, and that's gonna slacken our belt and let us get it off. Now moving on to the alternator and AC belt, I have loosened up this bolt right here. I have loosened up that 17mm jam nut on the back side, and I'm going to back out this 13 right here, and that's going to allow me to take the alternator, rotate it up and in, which will give me enough slack to get this belt pulled off. So you can see I got plenty of bolt out, but there's still some tension there on the belt. We just need to give this a little bit of leverage there, and you can see that with minimal effort, push the alternator in, and that's going to free our belt up. Slide it off our pulley here. Here we go. There we go. Belts are off. Alright, we are down to our timing belts, but we're not fully disassembled and ready to do the belt service just yet. Now, since we're here at the timing belts, you can see that the last guy went through and marked all of his cam gears. Now that is something I also do when I'm doing my services. However, I go back through when I'm done and pull those marks off. I don't like to leave them on there. Really no good reason why that's how it is. I think it's just kind of my OCD. I think it just looks better when you pull it off, and I don't really like leaving traces that I was in here, even though we know that these cars get timing belts all the time. So it's just my preference, neither a wrong way or a right way. That's just what I like to do. But now that we have everything off, you can see that right here is our water pump pulley, and this is our water pump right here. It's bolted into this separate water housing that bolts to the block right here in this little insert. But these water pumps are pretty unique because you don't really get a complete water pump from Ferrari. You can get this housing separate from the pulley, from the shaft, from the seal to the impeller. You can get all individual parts. And these seals are really unique because they use it's like a piece of carbon that rubs on another piece of the seal with a spring, and that carbon, if you install the seal wrong, will crack and break, and that causes a lot of problems and leaks. It is incredibly difficult to assemble one of these water pumps without the special tool to press in that seal. I've done it once before without the seal or the tool, and I think I went through 3 water pump seals to get it right. I think I broke 2 before I got the 3rd one in the right way. Get the tool with it. That just makes it a lot easier. When we're here, we definitely want to check this water pump, and this one, when I spin it quickly, it's fine. But when I spin this slow, you're probably not going to see it on camera. Right there, I can feel it. It gets a notchy. Right there, you can kind of see where it has like detents where it's going and stopping. Well, that could be one of 2 things. That could be our shaft and bearing. It's all kind of one assembly. Or it could be that carbon and that water pump seal. I could replace the seal separately and leave the shaft and everything in there and reuse it. But there's no way I could get the shaft out and reuse the seal. Usually once you press them out, they're ruined. You have to put a new one in. That one, I'm not too stoked with how it feels. I didn't have any signs that there was any issues with it when the car was running, but now that we're here and we're able to inspect it, it's one of those things where I'm probably going to talk to the client and suggest that we go a little bit deeper and spend a little bit more time investigating that water pump, because if we're going to do anything with it, now is the time. Over on to the bank 2 of the engine, you can see I've already pulled the spark plug wires off and I got the valve cover pretty much ready to come off. I took my throttle cable off the back side. I will say that they have these ground wires back here, and this one was loose when I got it. It was just like so. And this car did have some interesting check engine lights, and I have seen these loose ground wires back here cause that. And before I pulled everything apart on this car, I did take that ground wire and I wiggled it, and I also disconnected it just like so to see if I could induce the same errors that I was having, the same problems, to see if maybe that was it. And nothing really changed, although I only had the car sitting here idling and I didn't drive it, so not 100% positive if that was really the cause of the problem that I saw with the computer, but it's one thing we're going to note and correct on reassembly. So you can see over here I've left the spark plug wires and everything in. I haven't got that off yet. So the only thing to talk about that's a little bit different on the cam covers from bank to bank on this particular car is our camshaft sensor. So this is a 97, it's an ME 5.2 car, and it's a bit unusual, but they only use 1 camshaft sensor. There's not one on the other side of the head. So back here on the back of the head, there's no hardware coming in this direction. For the seal plates that my finger's on right here that kind of seal up where our camshaft goes, that just is an aluminum plate with a round O-ring on it that sits in a groove in the head and the valve cover, seals everything up. I say this because once you just remove all of your valve cover hardware, you can lift the valve cover off, and there's really nothing that you need to keep in mind back here on the back side of the head on the left-hand side of the engine. However, on this side, we have this cam sensor, and it's bolted on in 3 locations. If we look down there, you can see that there's one bolt right down there, and that bolt is bolted into the head. I can feel it back here, but there's another bolt right about right there, and that is also bolted into the head. And right here, there is an Allen that comes in that sits flush on the back of this housing, and that's bolted into the valve cover. You can see the boss for it right there. So at a minimum, we're going to need to remove this Allen to get the valve cover off, but I know we're going to be taking this entire housing off, so I don't like messing with it. I just take it all off from the get-go. So I disconnect my wire here. So get this off. Get that off and out of the way. I can move my connector out of the housing. That's going to give me better access to get to that bottom bolt. This bolt's a little bit tricky to get to. A flex head ratcheting wrench works nicely for that. And then get this Allen out right here. Now, on this early 456, I actually have a lot of space back here on this firewall, so this isn't too bad. But this is an area that I was talking about where I reference other cars, specifically like 550s, 575s, 612s. It gets much worse back there at the back of the engine, and this is one of the worst parts of that service, is getting all the hardware out that's bolted in or wedged in between the back of the head and the firewall. Fortunately, for the early cars, you actually have a lot more space in regard to the intake manifold and the back cam plates. On the later cars, you have much less space and it gets a lot more difficult. However, the newer cars don't have mechanical lifters, so you're not doing a valve adjustment. So it's kind of pick your poison. So that's kind of what I was saying earlier, referencing how this service takes about the same amount of work that it does to do an engine out on a 355, even though we're not removing the engine from the car. It's the same thing if you get to a newer car, say a 575, it has hydraulic lifters, so you think, man, that's a lot easier. You don't have to do a valve adjustment. That timing belt service will be quicker. Well, you end up burning all that time that you saved with the valve adjustment, working those back plates on the back of the cylinder heads. So in the end, it all just is a wash. They all end up taking the exact same amount of work. I'm going to get that back cam cap off, all that hardware out, get these other spark plug wires off the engine, and then bring you guys back so we can pull the valve covers. We made it all the way down to the valve covers. All the hardware is out and they're ready to come off. Now, I will say that these valve covers are glued on moderately well, and there's really not a great way to get them taken off. If you guys were watching the series of videos where I had the heads off that 355, I went through in pretty good detail of how to seal up the valve covers, and actually it drummed up quite a few questions and comments. It's definitely not the best system, but it's what Ferrari does. So there's a paper gasket that runs all the way along the perimeter of this rail, and it terminates right here. And then there's a round aluminum plug in the back side that's captured in the head and the valve cover that's sealed with an O-ring. And then we have a little bit of piece of paper gasket in the center here. And then this side, since we have the cam sensor, we have another gasket that comes on the back side that seals it up. We don't have this round plug. Same paper gasket running along the bottom of the valve cover, which terminates here. Another O-ring on this flange right here for our cam seal. Same thing right there. There is a piece of paper in the center that seals it up. Now the 355 we had used rubber O-rings around the spark plug tubes to seal that up. This uses that same paper gasket. Now, when I sealed that 355 valve cover up, I did use the 3-bond 1211 sealant, which is the less aggressive sealant that I have. And I did do an incredibly light layer on both sides of all the paper gaskets. That is pretty typical on these cars, and that's pretty normal. Now, I'm bringing all this up right now because if we know that we basically have those paper gaskets running all the way down the perimeter here, down the center, and all the way down on the bottom, and in all the grooves with our O-rings, that valve cover is, I wouldn't say glued on, but it's adhered on there pretty well, where we're going to have to pry to get it off. We're not just going to be able to lift it off. Now, I don't want to jump to what most people's instinct would be, and that's to drive a screwdriver down in between the valve cover and the head, because I don't want to mar the surface up or damage anything. The best method that I've come up with on getting these off, we'll see if I can't do this with one hand. I took a generic bolt and I threaded it into the boss where the bracket for the throttle cable goes, and just gave it a bit of a washer. And you can see I have my pry bar right there on my emissions test port tube, and hopefully with giving this just a little bit of pressure, it should start to release that sealant and come off. I can hear it coming up. There we go. So by doing it that way, I mean, the only thing in a worst case scenario would damage are the threads there or this emissions test cap. Both of those are pretty fixable, but I can tell you that I wasn't putting that much pressure on it to cause any damage. And now that we have it up, you can see, get that off. Bring this over here. So you can see the evidence of the last guy sealed it up in the same manner that I do. All that sealant around there. So again, that is all very normal and typical on how these are sealed up. Now if we look right here in our grooves, they have been beveled, so that's important so we don't pinch this back O-ring. I can't see if those ones been beveled. And this one's been staked a little bit too, although they're not very deep. So these are the stakes that I mentioned that we put in here to help keep that gasket from sliding out. I might go back and hit these ones again to make them a little bit deeper, since we kind of had some push out on these gaskets, to see if we can't make that a little bit better for the next time. But now you get a good view of the gasket. So everything for all the spark plug tubes, our upper rail up here, you can see that little piece up there where it transitions to our O-ring. So it's pretty much the same as what we saw on that 355. But I'm going to go ahead and get the other valve cover removed. I'm going to spend a little time and get these gaskets cleaned up, get them pulled off the head. And I'm pretty much running out of time today. I think that's going to take me to the end of the day. And then we're going to come back out here tomorrow because I need to run through the valve adjustment. And then we need to check and confirm the camshaft timing before we actually get into the meat of this timing belt service. All right, we're back on the 456. However, it happens to be 2 days later. Now, where we left off on the engine teardown, I actually had to stop and make a hard pivot because the client got back to me with the approvals for some recommendations on the car, and there was a couple items that I actually needed to get taken off of the car so that way I can get them sent out for repair. So I stopped where I was at on the timing belt service to get those parts off the car, because really I'm thinking big picture here. I need to be sure that I can get those parts off, repaired, and back to me before I have this car back together, because the last thing I want to be doing is waiting on those parts. So what I ended up doing is I had to get the radiator out, which was really the bulk of the work. So when we did our pre-service inspection on this car, the radiator was leaking pretty bad. It was leaking in multiple areas. I got the radiator out of the car and it's ready to go to sublet. And the other item, which was really not much to look at, is on the inside of the car. I had to get the airbag control unit removed from the car because if you remember, the car has an airbag light on, and I also have no communication to the airbag control unit. So with my SD1, no matter what I did, I couldn't get it to communicate. I went through, checked my powers, my grounds, I checked continuity of my communication lines to the airbag control unit, and everything checks out fine. It's showing that the control unit's getting its power, it's getting its ground, and I should be able to communicate with it because I have good wires from the communication line connector to the ECU. So that's removed, and both of those items are going to get repaired. Once they're back, we can get them back into the car. Now, I'll be honest with you guys, it's getting to a point with the work that I have lined up in the shop and my backlog of editing videos that I'm not able to go through and cover every single thing I do to the cars. I'm actually going to have to start picking and choosing what I'm doing just because of the time it takes for me to actually go through and film the work that I'm doing on top of editing it. My backlog of work that I'm doing in the shop is just getting deeper and deeper. Therefore, I decided just to go ahead and get that radiator removed and the airbag control unit removed. And I didn't cover any of it on filming. I was really just trying to get it done as quick as I could so that way I can maximize my time out here. Maybe on the tail end, when those parts come back, I'll cover all that work when they're going back in. But that will likely be on a completely separate video where we're covering all of the additional work that I'm doing to this car outside of the timing belt service. So let's talk about where we left off on this timing belt teardown last time we were out here working on it. And we had just finished removing the valve covers from the engine, and I went and spent a little bit of time getting all the gaskets removed from the cylinder heads and cleaned. Now, I will say that this is not my final clean. This is just kind of a rough down and dirty clean. I go through, and let me show you what I use. So this right here is my favorite tool to get the gaskets cleaned off just because of the size, and with the handle it's really easy to run it down the rail of the head and get everything cleaned up. Now I will warn you that when you're cleaning everything up, a bunch of junk is going to fall in here kind of in this little tray or trough where the cam sits. I go through, get all that stuff cleaned up, get all the gaskets scraped off. Obviously I do my best not to get it down in there. You can see like right there, there is a piece. But if some of that does fall in there, say for example that piece right there, I don't sweat it. It's not that big of a deal. I say this because in order to replace our camshaft seals up here, I'm going to have to remove the camshafts from the engine. So these seal plates, if you look, that O-ring is actually captured in a groove. So there's aluminum up on the front side right up there on that O-ring, which prevents you from sliding this off the front of the cam. Also, the inside diameter of this plate does not slide over the front of the cam. You have to slide it all the way off the rear of the camshaft. So in order to replace these seals, which for me is mandatory during a belt service, it's this O-ring and the front camshaft seal. The cams have to come out. Once the camshaft is out, that's when I'll go through and actually be sure I get any of that extra gasket or silicone that falls in cleaned out. So we'll just have the lifters in there. We'll have lots of space to get it cleaned. And that's also when I'll come through with a Scotch-Brite and scrub this rail and get any residual off. Like you can see that silicone right there. I'll come back and clean all that off at that time because with the cam caps off and the cam out, I have a lot more access and room and I'm not working around things. The work I did to get the gaskets off now was just the initial down and dirty, so I'm not working around all these dirty gaskets and they're not getting in the way. Now I say I don't want those gaskets in the way, and that's because our next steps are to go through and check and adjust our valve lash. So when I'm doing a timing belt service on any Ferrari with mechanical lifters, it is part of my standard service to go through and check and adjust the valve lash. Now, one might wonder why I'm going through and checking and adjusting the valve lash now on teardown, and there's a couple of reasons. One of the reasons is I want to get that data now before we really dig deep into the engine. So I don't want to go through and throw new belts on, new seals, have the cams out, do all the work we're doing to the car, then come back through and check our valve lash, because if we find something grossly wrong, something really, really tight, or something real loose that shouldn't be that way, there's the great potential that I'm going to have to undo all the work that I just did. So we want to go through and check everything now, because generally these shouldn't move very far at all. Maybe you're going to go up or down one shim size. It's very rarely you're going to make a big jump on your shim size. So let's say if I have a car and I find that there's a dramatic difference in my shim thickness that's needed, that tells me I probably should start looking a little bit deeper into what's going on, because that's a little bit unusual. The other reason why we're going to go through our valve lash now before we pull the timing belts off actually comes down to how we degree the camshafts in. So I'm going to work through all the valve lash on all 12 cylinders, but I'm actually going to have to come back to the front 2 cylinders on each bank. So the front intake cam, the front exhaust cam, And I'm gonna have to set those cylinders up at a specific valve lash. On this car, it actually happens to be 1/2 millimeter, which is far greater than the lash that it runs with. And I need to set that lash in there so that way I can degree the camshafts in. It's just the procedure that Ferrari calls out. So I'm gonna be monitoring the valve movement, accounting for that 1/2 millimeter of valve lash. So if my valve lash is either greater or smaller than the 1/2 millimeter, it's going to affect the camshaft timing numbers that I'm getting from the engine, and they're not going to be accurate. So since I'm going to have the tools and all my shims out setting the valve lash for those front cylinders so I can check the camshaft timing, I just go through and hit all the cylinders at once on the entire engine. And then at the very end, once I know I have all my cylinders lashed correctly, I come back to the front ones, I set them at my 1/2 millimeter, and then I can move into my pre-service cam timing checks. So I'm going to take a second and get everything set up here so that way I can show you guys the procedure that I use to check and adjust my valve clearance. Alright, so let's take a second and talk about checking and adjusting our valve clearance on this 456. Now before we get into the specifics of this 456, I will state that my preferred method to set valve clearance is to actually use a feeler gauge at the size that I want. So let's use 12 thousandths for an example. To use a 12 thousandths feeler gauge and adjust, usually if I have a shaft or a jam nut, adjust that, and I'll actually use the feeler gauge running it in and out to actually measure the drag and make sure I'm setting that up correctly. Now, I'm talking about this because that is not the method that I use on the Ferrari or really any car that uses a shim to set your clearance and your valve adjustment. And the reason why I do this is really when you have those shims, you only have a select range in your sizing of shims and you're kind of limited on the adjustments you can make. Therefore, if you're going for the perfect feel on drag on your shims, you're going to chase yourself in circles and drive yourself crazy trying to get it because you may not even be able to get it because of the range of shims that you have to choose from. So on cars that have a solid shim, I just jump to a go, no-go method. And is what I'll do, as you can see, I already have my feeler gauges set up here. These ones are for my intake, and I have a 8 thousandths feeler gauge and a 10 thousandths feeler gauge, which this is the minimum and maximum range that Ferrari gives us for setting our valve clearance on this 456. So our minimum range, it says 8 thousandths, our max is 10. The way I actually use these though is if my 10 doesn't fit, I take that as good. And then I make sure my 8 fits, and then I know my valve clearance is set correctly. And if that's the case, I'm setting my valve lash or my valve clearance at 9 thousandths. Using this method, although you're not using the feel and drag method, which I kind of like that, it's a little bit more craftsmanship-y, a little bit more skilly. It just kind of feels kind of like the old times. It's just something I like to do. This method still gives us a very precise and accurate result. So you can see that little trick that I did years ago is I actually purposely sought out this set of snap-on feeler gauges. I actually had to buy 2 sets because you can choose your handle color. So I bought a set with the yellow handles and a set of the orange handles because it comes with 4 handles per kit. And I actually divided the 2 kits and sold the other one, so someone else out there has my other kit. And I did this because I'm using these orange handles here for my exhaust clearance. My intake is the green handles. So this makes it super easy, especially considering when I have 48 valves to do, and I can jump from intake to exhaust depending on where my low position is and not worry about getting my feeler gauges mixed up. I don't have to remember which one is which. I just throw in my feeler gauges and my handles, and I essentially just can cruise through the valve adjustment and don't have to give it a terrible amount of thought or too much thought. So you can see that I have my shims up here, so if we need to make any changes, we have our tooling here to depress the lifters down and get the shims out. And I just have a pair of vernier calipers here that I use to measure the difference of the shims. And I'll say that I use those because, yeah, they're not great to get a true precise measurement of the thickness of the shim, but I'm not so concerned with that. I only need to get my old shim out, get a rough idea of how thick it is, measure the new shim, make sure it's one size larger or the smaller depending on what I need, and put it in, recheck my clearance. The thickness of the shim doesn't matter as much. The effective end result clearance matters, so I just use those calipers to get me close, put the new shim in, and verify it. So where I think we're going to go from here is I'm going to get some cameras set up. I'm going to use this valve right here since our cam lobe's already up on the base circle, and I'm going to show you how I check and, if I need be, adjust the shims, because I leave the camshafts in while I do this. Okay, so when we're checking our valve adjustment, obviously we want the lobe up, so we're on the base circle of the cam. Pretty simple. Take our 10 thousandths feeler gauge. And I usually try to slide them in from the side, and I can see that this one can't get it in, and I'm coming in straight on, and it's not fitting. And we'll take our 8 thousandths, and we can see that it slides right in. And this one kind of has some drag. It's a little loose, but we know that since our 10 doesn't fit and our 8's spot on, we're right at about 9 thousandths. But really is what we're looking for is for the 10 to not fit, the 8 to fit in, we're good to go. I will say that that is a little bit tighter than what Ferrari calls for, because they say that 10 thousandths is our maximum spec and 8 is our minimum, meaning I really could be running an 11 thousandths and a 7 thousandths to give us our full range. But since I'm going the go, no-go method, I like to tighten it up a little bit and keep my valve lash as tight and consistent across the engine as I can. We know that this one we're using here, it's fine. It's lashed where it needs to be. But I'm going to run through the procedure to show you guys what we need to do to make changes to it, so that way, if you're doing this on your car at home, you know what you need to take care of. In order to do so, there's a couple things to note, and one of them right here is there's this groove right on the lifter itself, on the bucket, not the shim. And I'll drop you guys in here and show you what I'm talking about. So this is that little groove right there on our lifter bucket. There is going to be one also on the top side, right up there. And it's important that when you're doing this and making adjustments that you have access to this little cutout right there. So I like to have it right in this position down on the bottom, opposed to this other one right here. You can't see where it's at, but you can see the little pocket screwdriver. You can just rotate them around, get them right where you need to be. So if you're going to make any changes or adjustments, be sure that you get these rotated where you have access to them. All right, so with that notch facing us, we're going to use our depressor right here, and we're going to slide this in between the cam and the lifter, depressing our bucket and valve. And we want to be sure that when we do this, that we don't rotate the lifter too much. It will have a tendency to rotate where that notch was set. So sometimes you might have to take your tool out a couple times and re-stab it, so that way it doesn't rotate it where you don't want it to be. I already saw on this one it did rotate it. It went to about maybe the 2 o'clock position, which is fine. We can work with that. And then we have this tool. This is a Hill Engineering tool, and it is a little holder that we're going to slide in under the cam, and we're going to get that in there to hold down the lifter so we can remove this tool. Now I'm going to grab a light, because we need to get in here and be sure that I have this on the body of the lifter and not on the shim itself. If we're getting the shim even just by a little bit, it's going to make it really hard to get everything out. So now that we have that tool in there, we pop our other tool out, and now we have everything depressed, and there's space in between the cam and the shim to where we can get the shim out. Now you may be tempted to try to use a magnet or something to get that shim out of there. I can tell you that it's probably not going to work very well for you, specifically because it's a pretty tight fit, but also because all the oil that's in there kind of acts like a suction and holds them down. So to get them out, a little bit of compressed air, and that's where those notches that we paid attention to on our positioning are important. So I'm coming through on the top side, because the bottom one, well, we'll get on the bottom one so we can show you guys. We're just going to get that nozzle right on there. I throw a towel to minimize the oil, and try to shoot it out with air. You should hear a pop when it comes free, but that did not come free. I can rotate my shim so it's not bound by my tool. Try the top one. If you guys heard that pop right there, that was the shim coming loose. And as you can see, voila, we have our shim out right there. And we can wipe it down. And most of the time on these shims, you'll still be able to read the numbering or the thickness on them. However, on this one you can't. But I generally, again, I don't rely on that, because sometimes accounting for wear or the numbering, it's hard to read. It doesn't really matter to me. So I'll just take my calipers on my shims, and let's say this one was too loose, so I'd want a thicker shim. I'll come in and measure it, and this one is about 409, so I'm going to round that up to 410. So then I'll just grab a 415, if I have one in here, 410. I'll grab a 415 shim, and I do the same thing. Even though this one has a number on it, I'm going to measure it. Be sure this one's showing 414. And then we're going to work that one in. Now I'm not going to change that shim right now, because we actually need to clearance this down for our cam timing checks. But I'm just going to put this one back in, because I'm going to do that last clearancing when I'm all done. So you can see that I can work it in pretty easily. And then I'll use my pocket screwdriver to seat it all the way in. Right there. And it's kind of the reverse of how we got here. We'll put this depressor back in, push down, pull our tool out. There we go. And then we can rotate our lifter bucket again. That tells us that we still have the right clearance. We don't have the shim wedged in there and not everything's bound up. It's really not terrible. It does take a little bit of a feel, and you do have to be careful that you get this tool in correctly. You don't want it moved too far out, like I mentioned, and you have it on top of the shim, because then the shims won't pop out. And sometimes it takes a couple shots of the compressed air to get the shim to pop out, kind of like what we had, but it will pop out. You grab it, make your changes, put it back in, wash, rinse, repeat until you get everything done. So really not too bad. You do have to have some shims, so there's an investment there, and obviously the special tools to get everything in and out. I suppose that if you didn't have these tools, if you wanted to, you could do this by removing and reinstalling the camshafts. However, I feel that there's more opportunity for risk there with potentially bending a valve depending on where your pistons are located within their travel. In my opinion, going to end up being more work than this method, pulling it in and out. Just not worth the risk, but if that's what you choose to do and you don't have the tools, do what works for you. So there's one more thing I want to mention, and it kind of comes back to why I went and took the time to clean the gaskets up before we got to the step. And that's because we have a lot of valves to check and adjust. I mean, 48 to be exact. Sometimes it can be hard to keep track of what you're doing. Yeah, I could go and rotate the engine over and go through the firing order of the engine, but that's going to have me bouncing from side to side of the engine, going from intake to exhaust. Really, workflow-wise, that doesn't work that great for me. I usually just have a ratchet up here on the crank pulley. I'll rotate the engine over and I'll just do the intake side on one bank, then do the exhaust on one bank, and then move over. If you do it that method, you can lose track of what you have and haven't adjusted. So I usually just go through, and since we've already made our adjustment theoretically on this one right here, I actually just take a Sharpie and I'll write OK right above my cam lobe on the head right there. And that tells me that I've checked and made the adjustment, or I'll just do an X, that way I know it's good. And then once I have all of them X'd, everything's fine. I know that I haven't missed any and I got them all checked and adjusted. And it's Sharpie, it's no big deal. Once we're done, just a little paper towel and a couple quick wipes and our mark comes off. Like I said earlier, I'm going to go through and have the cams out of the engine. So when I have the cams out, I'm already going to have all my valve clearance done. So that's when I spend more time cleaning the rails, and I'll get all the marks taken off at that time because I already know that I've gone through and gotten all my valves lashed. I think that's enough talking for me. I need to go ahead and repeat that 47 more times. Now, you guys might have noticed that I was doing some extra work here on the front of the engine, and you probably already spotted some extra tooling that we have not talked about yet. And that is because I ran through and did my pre-service cam timing checks on the engine. So we already mentioned that I went through and set my valve lash for that. You can see that I have my TDC gauge set up over here on bank 2. I started on bank 1, we just wound up over here on bank 2. So that's measuring my piston travel. And I'm using that gauge in conjunction with my degree wheel down here, which is bolted onto the crank balancer. You can see that I have modified my degree wheel so it fits tightly on my socket, it holds everything on. And I'm driving through the crank bolt, through the crankshaft, really not affecting the degree wheel here. These are my hardware holding it on. And you can see I have my pointers set up here. I have 2 pointers. They're 65 degrees apart because this is a 65 degree V12. And I do 2 pointers on my setup, my degree wheel, because ultimately it just saves me a little bit of time when I'm getting the cam timing done, when I'm going from bank to bank. I basically can calibrate one side, calibrate the other pointer at the same time, and then all I'm doing is a verification check when I move my tooling to the other side, and I don't have to reposition the degree wheel or completely reposition a pointer. Just a little trick, saves you a little bit of time. I got all that set up, set everything on top dead center, ran through and checked the timing belt tension on both belts again with our digital frequency gauge, got all of that information documented, and then I ran through and checked my camshaft timing on all 4 camshafts. Now, I will start by saying that I know who worked on this car last and did this last timing belt service on it, and I would be surprised if I found anything that was not right on spec considering who worked on the car. So what I found on our camshaft timing was on bank 1, our intake camshaft was only 1 degree off from the spec. So the spec is for the camshaft to be closing at 6 degrees before top dead center, and I actually had it closing at 5 degrees. I found that the intake cam on bank 2, dead on spec, right on the money at 6 degrees. And I actually found that both exhaust camshafts were closing 9 degrees after top dead center, so we're 1 degree off because the spec there is at 10 degrees. So it's really great finding that our camshaft timing is really on spec. It gives us some good data. Unfortunately, I don't know what the camshaft timing was recorded at when it was installed from the technician that worked on it, but it would be nice if I had that information, then we can see how much it had deviated from when he set the camshaft timing versus how many years it's been, how much mileage the car has seen, and the timing checks I had from now. Unfortunately, I don't have access for that information, but the fact that the car's been well past 10 years since its last set of belts and our cam timing is still right on spec is absolutely a great sign. It always just makes me happy when I get into these cars and find out that they've been serviced correctly and properly. There's not a lot of unusual things that I have to go through and undo to make the cars right again. Okay, so we've worked through all of the pre-service checks that we needed to do. We got all the information documented and recorded on the condition of this engine, the tightness of all of our belts, our camshaft timing. We've already worked through all of our pre-service inspections, and we have the car torn all the way down to the timing belts, and I'm essentially at the point now, since I have all the information I needed and all of our inspections are done, we are ready to finally get to the part where we're actually removing the timing belts from the engine and doing the timing belt service. Now, we've already covered quite a bit in this video today, and I actually would like to keep all of this stuff related to doing the new timing belts consolidated into one specific video. Meaning I would like to make the one video dedicated to removing the timing belts, replacing all of our camshaft seals, doing all of our cleanup and prep on the cylinder heads, getting the new timing belts on, getting them tensioned, and getting them degreed. Because we've already covered quite a bit in today's video, I think I'm going to save all that work for our next video upcoming on the channel. So I think that's all I'm going to have for you guys today on this 456 timing belt service. Obviously, we're going to have a lot more content coming forward on this car because we're only midway through this project. So you guys know the drill. Be sure to like, share, and subscribe. You want to be sure you get the notifications turned on so you know when my videos are released and uploaded. As always, guys, I appreciate the support, and I'll see you on the next one.